All right, so we're back. I'm back. Hope everyone enjoyed plotting. For those of you who are listening in remotely, you can see that okay. I want to start by just reviewing plotting. There's not too much to review with plotting because, as you guys noticed, there is so much plotting syntax. And so the goal of the topic is just to introduce you to plotting, and honestly, you don't really need more than that. Anything else that you want to be able to do plotting, you can really find with just a very base knowledge of how plotting works. And I think the thing to keep in mind with plotting is that you can customize almost anything. So if there's some way that you want a plot or figure to appear, there is a way to do it in MATLAB, which is the strength of MATLAB and the strength of being able to program. If you're using other post-processing software that plots things, you're going to be restricted to what is programmed into the software and what buttons are available and what options have been programmed in. And so what I want you to keep in mind for this particular class is that what a lot of people want to know is what are they going to be tested on, or what are they expected to know, and the expectation is that you're able to do basic plot commands. So you should be able in 2D plotting to know the difference between the different kinds of plots that we've talked about, which is a regular linear plot, which is just the plot command, and then all of the different log plots. So whether you log the x or y axis or log both axes. These are very typical plots used in engineering and analysis because if you don't do that and you're looking at data that changes vastly in order of magnitude, it's impossible to see it on a regular plot. You should also be able to customize and know the syntax for labeling the axes in the title. You should be able to change all the basic line properties using short and longhand. So that means being able to change the different line styles, marker types, and line colors. And that would be using the shorthand with the three digits, I guess you could say. But then also using longhand, like using line width 2 or line color, blah, blah, blah. When you start getting into the depths of changing the line properties, you should be able to read it. You should be able to read the code, but you should be able to write code with basic line property changes. And then some of the other things are changing, adding a legend, adding a grid, and then text annotations. You should be able to do all of those. And then the last thing is the set command. The set command is a really powerful feature that allows you to basically access any figure plotting property and change it. And so we typically just use the GCA call here, which just means to grab the current axes. But you can also label your axes and then call on them directly. But we are never doing anything complicated for that, so you can always just put set GCA and then choose your line or choose your property and then change its property value. If you guys have any questions about this set command, please let me know on Piazza or somewhere else and I can explain it more. But this is a very important thing to be able to do. For 3D plotting, we basically stick to looking at mostly analytic data or data that's already been created for you. And so all you have to do is just plug it into either Surf Contour or Effort Contour. They all just have different visualization features. You should be able to change the color map and add a color bar. Without a color bar, the data is just a pretty picture, so you want to be able to show what the values are. So this is what I would say listed on this slide is an expected that you know. This is also summarized in the topic summary page. If you log on to D2L, it's all there as well with some of the syntax included. Okay, so my tips for this point on is to now make sure that, because now we're going to be plotting in almost every lab, make sure that at the top of every file, in addition to typing clear all, that you also type close all. Otherwise, a new figure will appear or overwrite an existing figure, and it gets really confusing, and you can have like 100 figures open behind, and then you can't find the most recent one. So just type close all, it'll close all the figures, and the new one will pop up on the screen. So it'll be the first one. It'll come over the codes window. And then I wanted to just summarize the set command one more time. So I've already explained a little bit about the GCA, which just accesses the figure that you want to look at. It stands for current axis, but it's just whichever was the most recent one plotted. And then, like all things in plotting, you always just access the property name, which you can find in the help, and I'll try to remember to show you that today in MATLAB, because it's a really nice tip. And then you change the property value. So here I'm deciding to change the xticks to maybe when the original plot it had a tick every half. This would change it so that there was only a tick every one. And so if you've ever plotted in Excel, there's like major and minor ticks that you can adjust and change, and this is basically how you do it in MATLAB. And the grid lines just follow where these ticks are. And then if you want to relabel the ticks to something else, they can be relabeled to any string. You can also relabel them to numbers, which I don't know why you would ever do that. That's probably not a good thing to do. But the property name is xticklabel, and then the property value is then a cell array of strings. So those are my two tips for where we are right now. Since I'm in MATLAB, I thought I would just, let me just show you what I just said I wanted to show you about properties. So for example, when you were working on the lab, one of the things that you changed, maybe if you went for it, is I changed the label on the color bar in the last plot. And so if you want to see how to change and customize something like a color bar, you're just going to search the thing closest to what you want to change. So you could try searching contour, for example, but since I know it's customizing the color bar, and I know color bar is a command, I can try that as well. And when you just do help space the name that you're looking for, it'll just give you a brief summary in the command window. But if you go to the reference page, it opens up the help associated with that. And then if you ever want to change a property within a specific command or feature, you just scroll all the way to the very bottom of the help page, and there's always something called properties. So if you're in like a line plot, it's called line properties. Here it's called color bar properties. And then you'll see that there's just different categories of things you can change, and then under each category are the properties that you can change. So for example, if you go to tick marks, you can see that there is a property called tick labels and a property called ticks. So you can change the color bar to have 2 ticks, which is what I did, the 0 and the max, and then you can change the labels to be like cars and no cars. And you can either do this with the set command, or just like with plotting, you can like do it directly in the plot command. So if I wanted to change the line width of a plot, you know that you just access the property name line width, and then you change the value to 2. Sometimes the value is a number, and sometimes it is a string. So another property of the plot is color, and you can change it to the string red, or you can use the array to do the RGB color scheme. So just like that, you can do color bar, and then you can just access those properties. So you can change the ticks to 0 and 100, and then the tick labels to, I don't even remember which one was which, but something like this. And the thing to keep in mind with the syntax of using these properties is that you have to check to see what type of property value it's looking for. Is it an array? Is it a cell array? Is it a string? Is it a single value? And you see that all in the help. When you click down, it'll tell you what you can use. And once you know the property, you can go and just search for an example by just searching the property, like color bar ticks or color bar tick labels, and that might be easier for you to tell what the syntax is. I think most people prefer to just look at an example. All right, so moving on today to topic 4. The next 3 topics are the most difficult topics of the class. Everything is based off of each other, so you really have to understand arrays in order to do everything we're doing up to this point. We're going to plot everything as well, so you have to have some basics in plotting. But everything really builds from here, and then basically the 4 topics: arrays, logic, loops, and functions will be used in every single topic from here on out. And so it's really important that you get a nice base here and you spend the time to make sure you understand these things. And so make sure to ask lots of questions, especially the remote students. I'd really like to see all of you actually using Piazza more. So like as you're working through your Cody coursework for you guys, since you're not together, just post your question on Cody coursework. You shouldn't waste a bunch of time trying to figure something out. That's not productive because it's usually a syntax question. So just post a question and see if someone else has already figured it out, or if I'm on, I can post it and then everyone can see it. So for example, for that tricky one where you had to match the string exactly, just say like, oh, my string's not working, anyone else having this problem? And then I can just say, yeah, you have to verbatim have the exact string, and I could even type it out for you to put in there because it's not really what's being tested, and so make sure you do that as we move forward here. So to start off with logic, this is a topic that people have varying degrees of backgrounds in. Some people have had some logic in math classes and whatnot. But for us, it's going to introduce a new class or a new data type called the logical class. And this is the class that MATLAB uses to represent a Boolean data type, or a true false, or a kind of like a binary data type. So in MATLAB, the data type is called, the conversion function is called logical, I think. But if you would like to represent something as true, MATLAB uses 1. And if you'd like to represent it as false, it uses 0. And it used to be that these were actually different than the numbers 1 and 0, but now MATLAB treats them exactly the same as 1 and 0. So if you have arrays with true and false values, you can do arithmetic with them if that helps with the algorithm or the logic you're trying to develop. And so in MATLAB, all you do is you rarely ever create an array of 1s and 0s. Typically what you're doing is you're creating relational conditions that the result of are arrays of 1s and 0s. So that's what I'll show you next. So in order to start dealing with these Boolean data types, we're going to start looking at relational operators, and we've already used them a couple times when we've used the find command. because like I said, there's really not much you can do in MATLAB when you get started, so you have to start using things that you don't quite understand yet, and we'll always go back and revisit them. But relational operators paired with the true and false Boolean data type are a way to pose questions to MATLAB and have it produce a series of logic to solve a problem that you wouldn't want to solve typically because it's too repetitive. So relational operators are all pretty straightforward. They're what you would expect, both with the syntax symbol and what you're used to in math. So the first one is greater than, and it uses the greater than symbol. And then less than. And that seems really obvious because there's a symbol for it, but other programming languages don't use those symbols. They use, probably the most common is LT and GT for less than and greater than. And then there is greater than or equal to. So for some logic, you need to use include the equal to. In lots of the logic that we're doing, that's the case. And then, if you ever want to check if two things are equal to each other, in that case, you need two equal signs. And that's because what is one equal sign reserved for in MATLAB?
Variable.
Yeah, variable definitions. So, two equal sign is the equality symbol. And then the last one is not equal to. When we first start talking about logic and the syntax and how logic works, it's a little bit hard to connect it to its purpose. But the only thing I can tell you right now without starting an actual problem is imagine when we were doing the find command to locate, we used it to locate like which percentages were higher than a certain number in the find command. So the find command used that relational condition on the array to locate which elements of the array matched the condition. And so that's the kind of thing we're going to be using this for quite a bit. So what you can do as just a few examples is you can put in relational conditions into MATLAB, and when you use any of these operators to compare two things, the output will be a logical rather than a value. So let's do a couple of examples and then we'll try them in MATLAB just so you can see it. So if I do 5 is less than 3, the question you ask yourself when you're using any of these relationals is not that this is true, but to ask, is this true? So is that true? No, it's not true. So the output is going to be a false, a 0. Or if you did 5 plus 2 equals 7, remember it's not saying 5 plus 2 equals 7, which wouldn't make there would be so many errors for so many reasons if that wasn't a regular equal sign. But it's saying, is this true? And in this case it is, right? So we can move over, and you can see that in MATLAB, and I'll show you how you can see the class as well. Okay. So if you do the first one, 5 is less than 3, you'll see that the value that comes out is a 0. Let me see if no, I can't. Okay. It usually shows like the data type in here in the workspace, but then if you click on the variable m that I just defined, the relational 2, you can see that it's coming out as a logical class. But I'm not actually 100% sure about the zeros. But then you can still operate with it, which is not always the case in every programming language. And then if you do 5 plus 2 equals 7, comes out as a true. And I think one thing that throws people is that there's already these operators, so people don't think you can save them, but these are just logicals, so you can save them to a variable like n. So you'll have like double equal signs in there. You'll have lots of equal signs in there. Okay, so that's the basics of the relational operators. So now let's look at a little bit of the logical operators. Now, this is what MATLAB calls them, but they are the operators that are used to combine relational operators. So it's when you want to look at when multiple conditions are true. So let's say you have two different relational conditions. Logic, for the most part, would be either an and or an or in between the conditions. And so in MATLAB, if you want to look at when two conditions are both true, then you use the and the symbol that MATLAB uses is the ampersand, that symbol. And then the or symbol is a vertical line, which on a lot of keyboards it's the upper left, but it's with the backslash, the other slash symbol. And so those are the two symbols. But one of the things that if you've never taken a logic class before, if you've never really thought about logic too much, you do have to start thinking about what does and or mean. So and means that both things have to be true, and or means that either of the things have to be true, and it just depends on what the problem is or what you're trying to solve as to which one is relevant. But if you're familiar with these logic, when you do the and or the or, you also just get out a true and false, right? So if one relational condition is true and the other one is true, the output is also just one true or false, and it's true. Does that make sense? However, if you have two relational conditions with an and one of them is false, then the output of the two combined with the and symbol is then going to be false, because the and symbol says that both have to be true. But what's important is you to realize not only how the different combinations work, but that it still just gives you back one true and false, which is always what you're checking, is just if it's true or false. With or, they can both be true and the output is still true, or one of them can also be false. And then the output is still true, because either needs to be true for the or symbol. And then obviously if they're both false in either case, the output is false. Does that make sense, how to combine the ands and the ors? Okay, so there's two types of There's two types of these logical operators. And this is probably like the number one question that is I get about these logical operators. So the first type is all of the symbols are doubled. So the and symbol, the or symbol, and then there's one more logical operator that's just the not. So it's not equal, it's just not. So you just do the tilde, and it just does the opposite. So if something is true and you put a not in front of it, it becomes false. So if you ever want, if it's easier to develop the logic on the opposite of what you want, then you can just put the not in front of it, if that makes sense. It does come up sometimes because of the way that while loops work. But anytime you see these double, this is the normal logical operators, and they basically work by doing short circuiting, which has short circuiting come up yet in a pre-lab? Okay, it's going to come up. Is it in this pre-lab? Okay. So short circuiting means that as soon as the MATLAB knows that the statement is false, it stops checking the rest of the statement. So for example, if it's reading an and logical, and the first one is already false, then it's going to stop it. So these double symbols stop computing as soon as the result is known. And so you use these for scalars if you're ever trying to compare just scalars with respect to each other. So once we start using loops, we're going to be putting logical operators and relational operators within loops when we're just checking one element at a time. And so in that case, you can just use the double symbols, and that's what MATLAB, it'll bring up a little warning asking you to use it. But sometimes you're going to just look at an entire vector and compare the entire vector element by element, but it's going to all happen at the same time. So in that case, you just use the single and or symbol. And you wouldn't want it to do the short circuiting and quit out because you want to check each element. So you don't necessarily want all the elements to be true. Instead, you want to see another array of logicals of ones and zeros where each 1 and 0 corresponds with each element. So you can use the single when you're looking at logical indexing. And in MATLAB, it won't work if you do. You can use the single and double. I believe it lets you use it with scalars, but it won't let you do it the opposite way. So it'll just give you a warning, so you can just basically wait until it throws a problem. There's not really a way to misuse these, but you'll just see the error pop up. Okay, so I think I'm just going to show some examples now. So let me move over to MATLAB, and I'll show you a few of these. and see if you can at least just read them for now. So the first one I'm going to show you is, yeah, I'll just show it to you. You can just read it and see if you can see what it is. So I'm going to create a variable a, and I'm going to set the value of the variable to 0. And then I'm going to create a logical and relational condition based off of a. So I'm going to just type out the whole thing, and then I want you to read it and let me know if you think it's going to be true or false.
Right?
Yeah, so a is 0, so the first one is true. So the OR basically doesn't even need to execute the second one because it already knows the first one is true. So B is 1, which is interesting. This shows why short-circuiting works, because what would happen if it did check the second one? Have you ever tried to divide by 0 in MATLAB? Oh, it doesn't throw an error. It's only if you... Usually that becomes not a number. But actually that wouldn't throw an error either. But yeah, so this would be infinity, which isn't less than 10. So it would just read on the whole command. So let's try it with the single. So you can see that it doesn't matter for this case because it's just one number, so either of them would work. Let's see here. Let's try another one. So let's set a equal to 1, and then let me write out another condition here. So what do you think is going to happen with this one? What will B be? Yeah, so this is also going to short circuit, right? Because they both have to be true, and the first one is false. So it doesn't even check the second one. But if it did check the second one, like if this was an OR, there's an error because A only has one element. It doesn't have two, so this is trying to access the second element of two, or of A. And since that doesn't even exist, there would definitely be an error thrown, but this shows that short-circuiting doesn't even look at that second condition. Okay, so let's look at a couple of the a couple of the ones where you do need the 1 for it to work. So I'm just going to create 2 arrays. Actually, not 100% sure this is going to work. So MATLAB keeps changing this, that's why I have to keep checking it. It very easily interchanges between 1s and 0s and logicals. So because I put in the AND statement there, it just assumed that these were logicals, even though I just put them in as regular 1s and 0s. You used to have to, if you were going to create an array of 1s and 0s, you had to use the logical to convert it into logicals, otherwise it would not treat it that way. But here you can see that it's just comparing 2 arrays one by one with the AND symbol. So if the first 2 elements are both 1, then the resulting array is going to have a 1. And then it will check every 2. So these are both false, so they're false. The third one, there's only 1 that's true, so that's false. And it goes through and it does it element by element. So that's why you need the double. So I believe that if you put 2 in, that's when you're going to have a problem. And this is a very common error that people see, is when they have the 2 instead of the 1. So this is where you have to be careful about it. So let me show you an example that's more similar to what you're going to be doing in this lab. So in this lab, you're going to have some data stored in arrays, and you're going to be looking for a row of the data that meets a condition, and so you're going to be wanting to do this using this sort of logical indexing. And so what you can do is you can just call on the full array X, which has 4 elements or many more than that, and then put in the condition. So I want to know which elements have an X value that are greater than 2 and that have a Y value that are greater than 7. So just reading this, what is the output array going to be? Do you guys know? What's Z going to be? So which of these elements are greater than 2? The 3 and the 4. So the output logical will be 0, 0, 1, 1, right? And then which of the elements are greater than 7? Just 8. So if you put an and between them, which one is going to be true only? Only the last one. So you get 0, 0, 0, 1. So the output array tells you which elements were true. So what I wanted to show you is the strength of logical indexing. So this is probably the most similar to your lab. And I'm telling you, I'm teaching you this right now. And then by the end of the class, we're going to be using loops like crazy, and people forget about this. And so you can use this on any lab, any Cody coursework, any exam, and it's one line. And if you want to write this the way that we learned to write it in loops, it becomes very long. And so just don't forget this. So let's say that you had some data, and I think this is still your lab. I don't think I've changed this. So is it a trash lab? Have you guys looked at it? Okay. So in the lab you have like 8 different types of trash, and then about each trash you have some data, like how long it takes to decompose, how much greenhouse gas is emitted when it's decomposing, and the goal of the lab is to determine which type is the worst type based off of some conditions. So here I am creating a cell array that just places each type in a different element. And you want to use a cell array because then remember you can access the whole word rather than the letter. And then I'm just going to grab one of the, and there's 1, 2, 3, 4, 5. So I've just written out 5. There's actually 8 total. And then in a regular array, and you can do this however you want. I think I've posted the data so you don't have to type it out. I can't remember. In a regular array, I'm just going to write out the number of years it takes for each of these things to decompose. So remember, they match up. So the first element is glass, it takes 500 years. The second element is furniture, it takes 50 years, etc. So I want to find which of the trash types take greater than 350 years to decompose. So I'm going to use a relational condition on the entire array. So if I just go in and I do years greater than 350, the output of that is going to be the ones that are true are going to be 1, and the ones that are false are going to be 0. So it's 1, 0, 0, 1, 1. So those 3 are true. They're all greater than 350. Now what you can do is you can use this logical array to index the other arrays that are associated with the problem, and that's really what's nice about it. So for example, I can call this logical array, I can call it M, and then I can plug M, which is just a bunch of ones and zeros. I can plug it back into the other arrays like years. And what that does is it's going to only give me the elements of years that are true, and it's going to give me the values. So the output of this is going to be 500, 450, and 5,000. So it's exactly like the find command. That's what we did with the find command, if you remember. But the difference is the find command outputs the element locations, and the logical, when you just do logical indexing, it outputs ones and zeros. But they both can be used to access the array in the same way. So you can also go back and you can access the M values of trash, that cell array, and the output of that will just be the same 3 elements. And it's still going to be a cell array. And you don't even need to do an intermediate variable, as with everything. So I rarely do save stuff like that as an intermediate variable, because once you start writing bigger codes, you want to be careful about overusing variables to save intermediate things that you don't actually need later. So here you can just do years of years greater than 350, or trash of years greater than 350. Okay, do you guys have any questions about relational operators, logical operators, or logical indexing?
So years of years over 350, that's just looking for years over 350.
Yeah, so it's the same, these are the same.
But it's not saving it under years or anything.
No, that's true. So you might want to save this as a new variable. It just depends on what you're doing with it.
Okay.
Yeah. Any other questions? Okay, so now what I wanted to do is show you if statements. So you do a little bit with if statements in the pre-lab, but they're not used in the lab yet. They'll be used in the next lab, but there's a lot to introduce next topic, so it is a nice place to start talking about them. Also, you can't really do much with if statements without loops. It's pretty boring. But the if statement is going to be our first decision-making structure that we're going to start playing around with. And for a lot of things in an if statement, the way that MATLAB is designed to work with vectors and arrays, a lot of the different logic that you're trying to incorporate into an algorithm can be completely replaced by logical indexing, but some things can't be done vectorized, and so that's why we use if statements. But then if statements have other purposes that we use. But an if statement checks a condition, and if the condition is true, it executes a set of commands. So the syntax for an if statement is you write the word if, and then behind it you put in the condition, and that condition is going to be the relational and logical combination of whatever it is you're checking. And the wrapper ends with an end, and once you type this in MATLAB, it'll turn blue. And both if and end are, I forget what they're called, but they cannot be used as variables. They're reserved specifically for this purpose. So you know how you can overwrite intrinsic functions and other variables. You cannot use if or and for anything. So you'll see that they turn blue. And then everything in between the wrapper, the if and the and, are just a list of codes or commands, and they're only executed if whatever the condition is next to if is true. So if statements are used outside of loops to just check to make sure things are correct before you start doing calculations. So maybe you wrote a code where the inputs both need to be the same size. You could create an if statement around your entire code that checks first if that is true before it goes through and does the execution. So this is the basic syntax where you only check one condition, and if it's true, you execute the commands. But they can get, you can do a lot more with if statements. So there's a lot of different options. So the next thing is an if-else. So an if-else just allows for another set of commands to be executed if the condition is not true. So the wrapper goes if, and then the condition just like before, and then you write the word else, and then you write the word end. So that's the full wrapper, and all of those words, if, else, and end, those will all be blue. Everything here between the if and the else is the same as before. These commands are executed if condition 1 is true, and then these commands are executed if condition 1 is false. So with the example I gave you before, if you want to check to make sure something is the right size before you proceed, your else clause, like the else structure, could just have a display statement on it that says some warning message like, your two inputted arrays are not the same size, please re-enter and try again, but not execute any of the code. And then the last little bit I would like to show you is the else if. So the else if structure is the same thing. It starts with an if and a condition that you check is true. But then you have an else if and then an end. It's the same as the else, except for you can put in another condition here. So that way you can check if one thing is true, if another thing is true, and then those are the only two options. You can also have an if, else, if, else. So then it would be if the first condition is true, second condition is true, and then everything else. But all of these different options, it just depends on what you're trying to do and which one you want. But what is important about an else if is the kind of the same idea of short circuiting. So the idea is that if the first one is true, then it's never going to check the second one. So if the first one is true and the second one can be true, then this would have some sort of logical bug in it. It wouldn't make sense. So we do several different, for example, the next lab, you have to be careful about how you set this up, whether you're using else ifs and whatnot. If both things can be true, and you want to do things depending on that, then you need to have two separate if statements that are completely separate from each other. So you just have if end, if end. But if only one option is true, like for example, if you're trying to categorize grades and you can either get between a 90 and 100, 80 and a 90, 70 and 80, and only one of them, every score can only fall into one of them, then the else if is your best option because it'll be quicker. It will only check until it finds one that's true. Do you guys have any questions about